Hello, everyone. My name is Bezancon, and I'm going to present a work entitled Thin Multi-Resonance Metamaterial as a Broadband Noise Absorber. Olivier Doutre and Thomas Dupont are my PhD supervisors, and we are from ETS in Montreal. The starting point of this work is the multi-resonant metamaterials pancake. It is composed of a central perforation and the thin annular pores arranged periodically on the depth. This study focuses on a variation of the radius of the central perforation to improve the sound absorption. Two examples of profile can be seen on a 2D axisymmetric cross-section view on this slide. The transfer matrix formulation is used here. The common pore geometry, in red, represents the pore end effects between each main pore, in yellow, and the thin annular cavity. The propagation of the sound in this cavity is represented thanks to its surface impedance. We can thus build the matrix of one cell, then the matrix of the total sample, and thus calculate the absorption. The viscothermal losses are taken into account by using an equivalent fluid of Johnson-Champoux-Allard type in the main pore, the common pore, and the cavities. This model will be validated with the thermo-viscoacoustic finite element model. So the starting point of this, is the regular resonator with a constant main pore radius. We can see that this material has a first absorption peak at low frequency and fine and spaced secondary peaks at medium frequency, and also a stop bound with a drop in absorption from 2500 Hz. The first profile presented is a linearly decreasing profile. We can see that the secondary absorption peaks are closer and higher. Also, the stop band is shifted on the to higher frequencies. The second profile is of higher order with wider bands. We can observe that the secondary peaks are higher and the band gap is even more shifted. We can consider this material as a broadband absorber. The validation is done with a thermo-viscoacoustic finite element model with a good estimation of the frequency and absorption of each peak. The next step of this work will be to determine an optimized profile, then the manufacturing and experimentation phase. Thank you for listening.